So in this video, we're going to continue on further with our calculations in projectile motion. So last video, we had a look at this question here. So if you want a recap of that, have a look at projectile motion number 1 calculations. But in this video, we're going to look at this question. A missile is launched from ground level at 49 meters per second, 30 degrees above horizontal. You have to find the time of flight, the range of the missile, and the velocity on impact with the ground. So first things first, like I did with the last question, I'm going to draw a picture to show what it is I actually want to do. So ground level. There's my missile being launched, like that. Angle of 30 degrees. Initial velocity of 49 meters per second. So I need to find the time of flight. So before I can do anything else, I'll actually write down what I know. I know that my VI is equal to, or VI I'll call it, 49 meters per second. For this question, I'm going to define up as positive. So that means my acceleration due to gravity is going to be negative 9.8 meters per second. Squared. Okay. So the first thing I need to do in this question is to break up this velocity into its horizontal and vertical components. So if I draw it in my resultant at 49 meters per second, so this is my VI. So my initial velocity at the angle. The horizontal component is going to be here, VH. That remains constant throughout the whole motion because we're neglecting air resistance. And my vertical, my initial, bit dodgy. V0 of the vertical is there. Okay, so now I need to chuck in my angle of 30 degrees. And I can calculate the magnitude of these two vectors using trigonometry. Now I explained that in my first video on projectile motion, so I'll just go out and just do it now. So VI is equal to 49. So, alright, to work out this side, I'll use sine. Opposite over hypotenuse. This is the hypotenuse, rearrange, and we'll get that my opposite, which is V. Change the colour of it so it matches up what I've got. V0 of the vertical component is going to be equal to 49 times by sine of 30. And my initial velocity in the vertical component is going to be whatever that equals. It equals 24.5 meters per second. Now while I'm doing this calculation, I'll also do the horizontal. I'll have to use cosine for that. Adjacent over hypotenuse. Get that my vertical horizontal velocity is equal to 49 times cos 30. And that is 42. .4. So that remains constant throughout. So now I need to use the information I got from my vertical to calculate the time of flight. So I now know my initial velocity in the horizontal component, I know the acceleration due to gravity, and I can chuck that information into this formula here. V is equal to, so V final is equal to V initial plus AT. I'm going to be dealing with the components in the vertical direction for this because that's the direction that the acceleration acts. Now, in this flight, we see that we start off with a velocity. The component of the vertical direction is going to be at its maximum at this point. When it reaches horizontal here, the component in the vertical direction is equal to 0, and then it goes back to its maximum in the opposite direction. So if I calculate the motion from here to here, I can find out the time for half of the flight, times by 2, and I'll get the total time of flight. So I'll use this formula. My V final, because I'm dealing with the first half of the flight, from here to here, my final velocity in the vertical direction is equal to 0. And just have to rearrange to find t. So t is equal to Vf take away V naught over A. Now we know that the final is 0, so I've got 0 take away my 24.5 that I calculated before. Divide that by the acceleration due to gravity. Because we've defined it in the negative direction, it's going to be negative 9.8. And therefore my time then is going to be 24.5 divided by 9.8. This equals 2.5. So that's only half the flight. For the total flight, because it's a parabolic curve, and whatever we start with is going to be whatever we finish with angle-wise, and my horizontal velocity remains constant throughout the whole thing, the total time of flight is going to be equal to exactly 2 times t, so I'm going to get total time of flight is equal to 5 seconds. On. We have to find the range of the projectile, or the missile. So, we know the total time is 5 seconds, and because we broke up our velocity into its components initially, we know our horizontal velocity. So we're going to use this number to find out our range. To find out a range, we use V is equal to S over T. Rearrange to find S. S is equal to V times T. S is equal to the horizontal component of the velocity, which is 42.4. Times by 5 seconds. And we get that 42.4 times by 5 is 212.5 meters. So that's the range of our missile. And the velocity on impact with the ground. Now I can calculate this correctly, or I can just automatically say straight away that because I've got a parabolic curve with no air resistance, my starting position, and it's starting at ground level and it's finishing at ground level, the component of my velocity that I get that's vertically here initially will be the same but opposite direction as what I get here because of the parabolic curve and because it's starting at the same point as it's finishing on ground level. So straight away I can say that my V in the vertical direction final is going to be equal to negative V0 vertical. So therefore VV final is equal to 24.5. It's equal to negative 24.5. So when I come to drawing the vector diagram for this, the negative represents as going in the opposite direction to what it once did. So my horizontal is going to be, again, the 42.5, 0.4. meters per second. My vertical is going to be 24.5 in the opposite direction to what it was originally. It was originally up, but now it's down. So therefore my resultant is going to be in this direction, angle here, and my V resultant is going to be equal to my V initial. In magnitude, the direction, however, is going to be in below horizontal instead of above horizontal now. So VR is equal to 45 meters per second, 49 meters per second. Double check that I've got that right up here. Yep. But the angle now, instead of being projected above horizontal, it's being projected below horizontal. So it's at 30 degrees below horizontal. So we've now answered this question here. A missile is launched from ground level at 49 meters per second, 30 degrees above horizontal. We found the time of flight, we found the range, and we found the velocity on impact with the ground.